Hello YouTube, Validation Boy here. There is a pivotal concept which has been used in the case for the flat earth theory that I feel needs a bit more analysis as we move forward. Certain skeptics of flat earth theory have unfortunately attempted to use this same concept in an effort to cast doubt on the beliefs of flat earthers, but I think I'll be able to solve that problem in this video. To properly analyze the arguments involved with this issue, I will be using a two-dimensional circle representing what is the assumed shape of the Earth. The issue we are discussing does not concern all of the other variables involved in a typical flight, but a cross-section of a theoretical sphere will suffice for the following arguments. Of course, what I'm talking about is the idea that airplanes, if flying around a sphere, would be required to occasionally adjust their nose downward, or at the very least slightly drop in altitude as to avoid flying off into space. Many flat earthers argue that if an airplane never adjusted its altitude to remain flying at a set distance from the surface of a curved Earth, the airplane would eventually travel farther and farther away from the ground. If we assume the Earth is a sphere, then at some point during flights of significant distances, it seems as though occasional adjustments would indeed be necessary to avoid such a disaster. Since we already know that airplanes do not fly off into space on insane trajectories, we can use a bit of logic and come to some other highly pertinent conclusions concerning this issue. Obviously, diagrams, just like mathematics, are in no way empirical proof of anything which exists in reality. Fortunately, the diagrams I will be presenting have little to do with math. In this first diagram, we see what flat earthers say would have to happen if an airplane flying around a sphere made no altitude adjustments to compensate for a ground that is curving away from the bottom of the airplane. As the airplane continues to travel in a straight line, the distance between the belly of the airplane and the ground would increase exponentially. Some skeptics of flat earth theory have argued that an airplane's nose would never actually have to dip to retain a constant altitude around a sphere, because a sphere's surface will always remain parallel to the belly of the airplane as that airplane travels around it. This is of course utter nonsense, as a curved line and a straight line can in no way be considered parallel to one another. One person I spoke with on these matters argued that the center point of the assumed sphere Earth would act as an axis point, keeping the belly of the jet and the ground basically parallel throughout a flight. I believe the word he used to describe the relationship between the linear bottom of the airplane and the abstract point at the center of the Earth he wants to assume exists was perpendicular. Well, parallel and perpendicular do not mean the same thing. In fact, the term perpendicular inherently describes two lines which cross each other at a 90-degree angle, as demonstrated in this diagram. To say that a point, such as the center point of the sphere Earth that the airplane is flying around, and a line, such as the line that comprises the belly of the airplane, are perpendicular, is a huge error. A straight line and a point cannot, by definition, be considered perpendicular. We can of course create an imaginary line stemming from the center point of the sphere, which will cross the line that is the belly of the airplane to create a perpendicular situation, but this is not reality. That imaginary line exists only in a fantasy world, and is merely based on the assumption that the Earth is a sphere, which is something that we all agree cannot be proven. Another argument that I've heard used against the nose-down altitude compensation idea states that some airplanes may possibly travel at a, quote, angle of attack, which means their nose is always lifted slightly upward, even though the airplane continues to fly at whatever fixed altitude has been predetermined. This fact is, however, completely irrelevant, as we can see in this diagram that if an observer chooses any point on that airplane and trajects it forward, that point will generally remain traveling at its own fixed altitude. On top of that, if the airplane is flying with its nose consistently tilted upward, then the odd angle at which the airplane is traveling can only be mathematically surmised in contrast to what would have to be a flat and level surface beneath it. The idea that an airplane could travel in what would be a consistent, yet not necessarily straight line around a ball without ever dipping its nose depends entirely on the relative size of the two objects being discussed. Airplanes and the Earth exist on a very specific scale, and such scales need to be taken into account when pondering such theories. In the end, it is clear that the argument against the nose-down altitude compensation is null. Airplanes never behave in this way, and that's probably because the Earth is indeed a flat and stationary plane. Please leave your comments below, and thanks for watching.